Hello dear students, hope you are doing well. Today, through this video, I'm going to teach a very important chapter in class 10 science. The name of the chapter is Chemical Reaction and Equation. So the first topic in this chapter is chemical reaction. Now the first question comes like, what is chemical reaction? Chemical reaction is a process. Okay? Chemical reaction is a process where one or more substance will form a new product or a new substance. Say for example, A plus B is equal to B. Now here A and B will form B. So A and B are known as reactant, whereas the substance which is formed is known as product. Now the question is, how do we find whether the chemical reaction has taken place or not? There are different characteristics. You can check the color. If you see change in color, that means the chemical reaction has taken place, the reactant has formed product. Or you can find out from the change in state, like if the reactant is solid, becomes liquid, or the reactant is solid, becomes gas. So if there is a change in state, that means the chemical reaction has taken place. Third, if there is a change in temperature. Temperature, you can say if there is a rise in heat, that means the reaction has taken place. So in a chemical reaction, you will find a reactant and product. The reactant is written on the left hand side and the product is written on the right hand side. A reactant or reactants are the new substance which will form a compound which is known as product. Next topic which we are going to study is chemical equation. Well, chemical equation is simply the representation of chemical reaction. Like a chemical reaction is taking place. How will you represent that on paper? We represent with the help of chemical equation. Now there are two types of chemical equation. Word representation of chemical reaction and symbol representation of chemical reaction. So word will represent the chemical reaction with the help of word, whereas in symbol representation we'll use the symbol or the formula of different types of elements and compounds to represent the chemical equation. Let us see with the help of an example. Zinc and sulfuric acid forms zinc sulfate and hydrogen gas. So this form of chemical equation is known as word chemical equation. Whereas the same reaction, if you write in symbol form for zinc, we'll use the chemical symbol of zinc, that is Zn, plus chemical formula of sulfuric acid is H2SO4. So when zinc reacts with sulfuric acid, it will form zinc sulfate and hydrogen gas, that is H2. Now most of the time the chemical equation is unbalanced. Now what is unbalanced? Let us see with the help of an example. Let us consider this reaction, the reaction of iron with water vapor to form ferric oxide and hydrogen gas. Now if you look at this reaction, the left hand side is reactant, right hand side you have product. Now on the reactant side you see you have Fe. How many Fe do you have? You have only one Fe. But on the product side you see you have Fe2, that means you have 2 Fe. So you can see the number of iron on the left hand side, that means on the reactant side, and on the product side is not equal. Similarly, you can see you have 1 oxygen here, whereas on the product side you have 3 oxygen. So whichever chemical equation having unbalanced number of atoms on reactant and product side is known as unbalanced chemical equation. So in the next topic we'll see how to balance this chemical equation. So there are a certain number of steps involved in balancing of chemical equation. So the first step, write down the unbalanced chemical equation. So I'll take the same equation so that it will be easier for you to understand. So let us take Fe plus H2O gives Fe2O3 plus H2. So what you'll do, you'll draw a box. Next step, you write on the element, reactant, product. So what are the different types of element involved in this chemical reaction? Fe, we write Fe, H, that is hydrogen, O, oxygen. Now let us check how many Fe do you have on the reactant side. You have only one Fe, so we'll write here 1. How many hydrogen do you have on the reactant side? 2, so we'll write here 2. You have 1 oxygen, so we'll write 1. On the product side, you have 2 Fe, so we'll write here 2. 3 oxygen, so we'll write 3. 2 hydrogen, so we'll write 2. Now from this you can see Fe, reactant, you have only 1, product, you have 2. Hydrogen, reactant, you have 2, product also you have 2. So this is fine, this is balanced. Oxygen, you have 1 on the reactant side, 3 on the product side. Now in the next step, we'll start balancing this equation. So we'll start from the compound or molecule having maximum number of atoms. Okay? It's not that you can't start from the atoms or the molecules with lesser number of atoms, but it's easier to balance when you start with the molecule or compound having maximum number of atoms. So step 3. So in this chemical reaction you can see here you have only 1 atom, 2 plus 1, 3. Here you have 2 plus 3, 5 and 2. So this molecule has maximum number of atoms. So we'll start from here. So you can see you have 3 oxygen, here you have 1 oxygen. So first we multiply this by 3. So now on right hand side, that means on product side you have 3 oxygen, on reactant side you have 3 oxygen. So the number of oxygen is balanced. Next we'll balance Fe. You have 2 Fe here, so we'll multiply this by 2. So now you have 2 Fe on the reactant side, 2 Fe on the product side. It's balanced. Next, let us check the hydrogen. Now hydrogen you have 3 multiplied by 2, that is equal to 6. Whereas on the product side you have only 2. So what you'll do, you'll multiply this by 3. So this is the balanced equation. So in the next step, what you will do, you will verify it. You will verify, you will check whether it's equal or not. Once again, so 2Fe plus 3H2O gives Fe2O3 plus 3H2. Now let us check whether it's balanced or not. So you have 2Fe, you have 2Fe. You have 3 multiplied by 1, 3 oxygen, you have 3 oxygen. You have 3 multiplied by 2, 6 hydrogen, you have 3 multiplied by 2, 6 hydrogen. So this chemical reaction is balanced. Now in the next step, you will write the physical state of the substances involved in this reaction. So 2Fe. So Fe is in solid state, so we'll write S plus 3H2O. So we are using the vapor, so it will be gas, that means G. Gives Fe2O3, which is solid, plus 3H2, which is gas. So this is the complete balanced equation. Okay? So you can take some more example from the textbook, try to balance the equation yourself. Okay? Now let us go to the next topic, which is types of chemical reaction. So the first chemical reaction is known as combination reaction. So from the name itself you can see combination, that means to combine. So in this reaction, 2 or more reactants will combine to form a single product. Okay? 2 or more reactants will combine to form a single product. So for example, A plus B gives C. So you can see you have 2 reactants here, that is A and B forms only one product, that is C. So this type of reaction is known as combination reaction. Let us take one example. CaO, calcium oxide, which is also known as lime, plus CO2, that is carbon dioxide, combines to form CaCO3. So you can see here, 2 reactants will combine to form a single product, which is an example of combination reaction. Next is decomposition reaction. Now you can say decomposition is the opposite of combination. In combination, 2 or more reactants will combine to form a single product, whereas in decomposition reaction, a single reactant will decompose, that means will break to form 2 or more products. So for example, you have P here. So P is a reactant which will decompose to form Q plus R. That means a single reactant will give 2 products, or it can be more than 2. So such reactions are known as decomposition reaction. Example, CaCO3, limestone again. So limestone on heating at 1000 degrees Celsius, it will form CaO plus CO2, that means lime plus carbon dioxide. Now you can see here, single reactant decomposes to give 2 products. So this is an example of decomposition reaction. Next, we'll be studying displacement reaction. In case of displacement reaction, cation in a reactant is replaced by another cation. Now for this kind of reaction, we follow activity series. Now we have this activity series where the metals are arranged according to their reactivity. Let us take an example. Zinc plus copper sulfate will give zinc sulfate plus copper. Now you can see here copper sulfate. Copper is the cationic part, sulfate is anionic part. So now zinc, being more reactive than copper, will displace copper from copper sulfate. That's why it's known as displacement reaction. That means the more reactive metal will displace the less reactive metal from the compound. So when zinc displaces copper from copper sulfate, it will form zinc sulfate and copper. So this is an example of displacement reaction. Next is double displacement reaction. Now in case of double displacement reaction, there is exchange of cation in the compound, okay, which is involved in the reactant side. So let us take this example. ZnSO4 plus HCl. Now here the cationic part is zinc, anionic part is sulfate. Here cationic part is hydrogen, anionic part is chloride. So zinc will take chloride, H will take sulfate. So we'll form zinc chloride and hydrogen H2SO4, that is sulfuric acid. So this is an example of double displacement reaction. Now why we use the term double? You can see zinc is displaced, hydrogen is also displaced, so there are two displacements taking place. That's why this reaction is known as this double displacement reaction. Okay, thank you. That's all from this chapter. Okay, we'll start a new chapter in the next class. Thank you.